Today I want to talk to you about code sharing, okay? So it's all going to be about how you build mobile applications and web applications using the same code. So the whole idea is like, you know, if you know Angular, you know how to build web and mobile, okay? So my name is Sebastian Witalec, like just he introduced me. If any of you is on Twitter, I'm Seba Vita, you can follow me. I'm this close to 2,000, so I really appreciate the extra 21 people. This is, by the way, how much 21 is, okay? So let's start about the story. So the whole thing is like we have to understand why we're using mobile, why we use web. So usually when you build mobile applications, native applications, we're looking at the situations of people who keep coming back to reuse your service, right? And then statistically, if you look at it, like people spend like over 18 times more using the mobile applications than for the web. And then usually it's like this kind of scenarios, like if you go to Amsterdam and you want to go to Van Gogh's, let's say if you live in Amsterdam and you want to go to Van Gogh's museum over and over again, you're going to download the application, which will give you like notifications, etc. And you can always check it like every week what's going on, right? Has he drawn any new pictures or paintings or stuff? You never know, right? Maybe new ears will appear. And this is the kind of case like where you keep coming back, or especially if you use like bus service in a city. But then on the other side, web applications are a lot better for the wider reach. So websites usually get a lot more people visiting. And if we come back to the Van Gogh's museum, it's like if you go to Amsterdam just once in your life and you want to go to that museum, you're not going to download the application, you're going to go and use the web app, right? But the whole thing is, like Luke Wroblewski says, it's not about one versus the other, but about using both, because there are good use cases to use web and good use cases to using mobile. And that's the whole story. So the whole thing that we want to achieve today is basically this. We have Angular that allows us to build Android, iOS, and web applications, right? And how we can do that, is because we have NativeScript, which kind of like two years ago when Angular 2, when it had a 2 next to it, came out, we were talking with the Angular team, and they said, like, we like what you did so far, how about you create an integration with Angular? And then, yeah, we said, like, yeah, that sounds pretty amazing. And then for those of you that actually don't know what NativeScript is, it's basically an open source framework that allows you to build mobile applications that with native UI, and you can target both Android and iOS, and you can reuse your skills. So you can use JavaScript, you can use TypeScript, CSS, all sort of that. And as a result, you get 100% native performance. So imagine a scenario, and this is me coming back to Angular, how everything is possible. You want to build a simple login screen, right? And usually we'll start with building a service. So that service will have some parameters. We have like a function that performs the login operation, another one that allows you to register, and you have some other functions like logout, etc. Then after that, we need to create ourselves a component. So, that was the same service. Interesting. Oh yeah, then we have a component, and then basically you would use dependency injection to drop the service into your component. And then you expose, let's say, the login function and maybe sign up function that will be using the service underneath, okay? And then so far, none of this actually says whether this is a web or a mobile application, because it's just platform agnostic. It's only when we get to the HTML part, so let's say we try to build the web template. So this is how we would do it for a web application. We would, let's say, add a label with an input. We bind to user email and the user password. Then we have a couple of buttons, which we'll call on-click login, and then sign up, all right? And then if we want to reuse the same component for NativeScript, we'll have a NativeScript template. So in this case, we're not going to use input, but we'll use a text field instead. But we still can bind to the user email and still bind to user password. And also, we're going to add a couple of buttons. This time, we're going to bind to a tap event, because you don't click on your phone, you tap. But we still call the same functions. And this is kind of like the premise of how we actually can start thinking of the whole code sharing, right? So like, okay, so the HTML is different, but the code underneath that drives the whole business logic is pretty much the same. So let's look at this from this perspective. So there's some key differences between Angular and the NativeScript Angular projects. So one of them is the project structure. So for example, in terms of Angular, your code will sit inside the source app folder. In our case, it actually goes straight to app code, which kind of like, it sounds trivial, but might create some tiny issues when it comes to the build. Next thing is, with Angular for web, you use Angular CLI. For NativeScript, we have our own CLI. Okay, so there's a NativeScript CLI, so you're not going to run ngserve to build an application. We'll run TNS, run iOS, for example. And then the biggest difference really is the UI. So your web components or mobile components and your styling is actually different. Okay, so this is basically where the biggest difference sits. But then in kind of like, from the bigger point of view, what we're looking at is, for example, we have the CSS, which is different, but it can kind of derive from the same Sass file. Also, like I mentioned, the HTML is different, so they kind of split. But all your HTTP components, Angular services, pipes, routes, they kind of can work from the same thing. And as a result, you can get 3 different applications coming up, right? So we're really looking at anything that is pretty much TypeScript, pure Angular, or Sass. You can reuse that across all 3 of them, okay? Which is pretty cool. So what are possible solutions to achieve that nowadays? So one of them is you could create like this approach of multiple projects. So you could start with this shared folder with like all your services, components, etc. that are completely platform agnostic, and then create separately 2 projects, one for Angular Web and one for NativeScript. And then you basically copy and paste your shared folder inside, which are basically just the same copy of the same thing, and then write separately the business logic for both. This approach, like if you look at the good, bad, and the ugly, or pros and cons, like normal people call it, the good part is pretty much, this is pretty easy to set up. It's good for small projects, and there is no learning curve. So if you know individually how to use NativeScript and individually how to use web Angular, you're at home. There's no kind of like weird things happening. The bad thing is that you have all this code duplication, and this doesn't really scale well. Like it's good for small projects, but it's better if it stays there. And pretty much the maintenance is really the ugly part. So unless you're building like a very small application of like 3-4 screens, I think you should steer away from this approach. The other approach, which is my favorite, is the MonoRepo approach. So we're talking about having one project and everything sits inside. So for example, we would have all our pipe services, but for example, our Sass variables for styling, which would then be used to derive 2 different style sheets. So it will be one for web, one for NativeScript. For example, our components, each component will have one single TypeScript class, but then you would have 2 separate HTML files within that component. And then even modules, which would share the components, would share the navigation, but then would have different ng modules. Because maybe you'd want to import Angular material for the web, but for NativeScript, you would import NativeScript UI, which is like the advanced components that you can use. So once we have this MonoRepo, then what we need is some sort of build process that can take, for example, for the web, the shared elements and the web-specific, and then spit out a web application. Or basically do the same thing for NativeScript, where it ignores the web-specific things, but takes the shared and the NativeScript files, and then gives you a NativeScript project, right? So let's look at the good, the bad, and the ugly again. So the good part is you can actually use Angular CLI for all of it. It's really good. This approach is very good for complex projects, and everything sits in one place. So it's actually really easy to follow. The maintenance is actually quite nice. The bad part is it is basically an overkill for small projects. The actual build process is more complicated than like a 2-page component type project. And the fact that you need to build the additional process is kind of a bit of a problem for a lot of people, because it's like, how do I even start, right? This is the kind of the ugly part, where it's like you're thinking, yeah, I really like this MonoRepo, but how, right? So let me explain that. So there's a whole bunch of projects that we've created, or people from the community created. One is the advanced seed from Nathan Walker. I actually didn't add it to my slides, which is very good. This one is from Team Maestro, which is my personal favorite. They actually published some real applications and websites using this seed, so it's actually battle tested. And basically, this seed allows you to clone it and then build your project for both web and mobile, which has all the build process. So let me explain you how it works. So if you have this MonoRepo project from the Angular native seed, and you want to build a web application, it's business as usual. You just run ngserve, and this will trigger Angular CLI, and then it will give you a web application, okay? For NativeScript, we have actually a custom build process. So instead of using TNS commands, which is the NativeScript CLI, what you have to call is npm run, either iOS or Android, and this will go in 2 steps. The first step, you run through a gulp process, and you recreate a NativeScript project, okay, taking the shareable files and the common ones, and then as a second step, you run through the NativeScript CLI using that recreated project, and then we'll give you a native mobile application, which is really cool. And then, for example, how do we do the whole code splitting? So your components, you would have TypeScript files and then the web HTML, native HTML. And the way it really looks is like if we have something called like name component, you have 3 files, name.component.ts, which is for both. Then we'll have name.component.html. So far, so good. That's for the web. And then if you add the prefix, the .tns HTML over here, that basically makes it a NativeScript specific file. And for example, if you want to add style sheets to that, you could basically just do the same thing. You could just add yourself a name.component.tns.scss, and this will be a style sheet specific file for NativeScript. So what are the challenges? There's a bunch of challenges, given that very often we'll be playing with different APIs and like the way they're implemented. And basically, there are kind of 2 ways of dealing with that. So if you have the same library, and I'll give you an example later on, that is basically implemented in 2 different ways, then we can either create a service at the Angular level that kind of like covers the differences, or we could create like a higher abstraction before we even get to creating services. So let's look at the service abstraction idea. So imagine we have this new cloud database called Pigeon.js, okay? And we want to call to it, and they both have their own plugins, like one web plugin, native plugin. So what you could do is just basically create yourself 2 different services in Angular, and then implement your business logic twice, but then those 2 services would have a common interface, right? So maybe there you have get data, update record, etc. You would actually have the same naming convention, so that later on from your components, you could just go straight, reuse the service. Another way of doing that is actually creating like a higher abstraction. So what you could do is create 2 wrappers, which follow the same common interface, but have no business logic of your application, which basically means now we can reuse this Pigeon.js library across all your code sharing projects. And then you can build your service with the business logic, which kind of talks to the components. So that's kind of the approach I used for this, where I was, in my demo application, which I'll show you later, I was using Angular Fire and NativeScript Firebase, which were very, very different. So some of the challenges I faced here was even the user models were completely different, okay? So we're looking at having UID, email, verified email, refresh token whenever I get a record. However, then the problem starts when I want to get the name. Like on web, it would be called display name. In NativeScript, we would call it name. Then you would have photo URL versus photo image URL. And as soon as you have that, TypeScript start complaining because it's like, I want to have one or the other. So obviously, the solution was in my abstraction to create like a common, like a user model, create a parser that basically every time we return the user, would parse it always to the same standard. So this is the Firebase user I created in my demo project. So I said, okay, in my opinion, all of the Firebase user objects should look like this. And then, for example, whenever I was calling the parse user, I would just take the user object and then assign each attributes individually. So, for example, if you look at the photo URL, you have we assigning profile image URL. Okay. That's the whole idea. And then, for example, we have display name, and then we have username over there, which is pretty cool. And then finally, to use the parse, all you have to do is, for example, I'm calling await firebase.login, and when I get the result, I'm just calling parse user, and I'm returning the parsed record, so that we always are consistent, regardless whether we're in web or mobile. So that was the easy part, okay? The harder part came here, because it turned out that Angular Fire was based on observables, while the NativeScript plugin was completely based on listeners. So I had to call add listener to get the data. So the whole thing is like, these are the two approaches. So this was web. So if I called my Angular Fire database, I would get an af.object, and that would give me an observable. In NativeScript case, I would have to call add value listener, and then basically do something every time that callback came back. So the solution was basically take that listener-based approach and then convert it to an observable. So I'm creating a new observable, calling add value listener inside. I'm also getting like a handle for the listener every time that happens. And then every time that event triggers, I'm just calling subscriber next. So basically I'm saying like, okay, my observable is gonna notify you of new results. And then as soon as somebody unsubscribes from this observable, I'm just calling remove event listeners. So then I can actually release the resources. And then by doing that, I was able to actually convert the NativeScript library so that it was actually on the par with the web library. So that was fun. Okay, so I managed to do. There was a couple of other issues I had to handle, but let's say I managed to handle my Firebase libraries, and I was able to use it in my project. The next thing is like in NativeScript, we have some additional extensions over some of the things that we can do. So for example, when you use the router navigation, we can in NativeScript also pass additional parameters. For example, you can add a flag to clear history, or a flag to trigger a native animation. So for example, the screen can flip from one side to the other, or just do like a page curl, etc. However, when I try to, and I can call it like this, add flip, duration, but if I call the same router navigation from web project, like TypeScript is gonna go batshit crazy. It's just gonna, like, whoa, what's going on? I don't think I like that. And this causes a problem, because if I have a TypeScript file, and from my component, if I want to navigate to another, all of a sudden it doesn't let me do the navigation, and I'm kind of like, I'm having an issue. So what I did instead, using the same approach of like having the .tns, .ts approach, I created like a service that just deals with the navigation. And then basically added the two additional interfaces, which can take flags for the clear history, where it's animated, what sort of transition we do. And then, for example, this will be my navigation service for the web, which adds the additional navigation options. And then the NativeScript one basically takes it by default. So what happens is now that if you do pass the additional options in the extras for the web, it basically will get ignored. But for NativeScript, you will use that and then perform that native animation, which is pretty cool. So it's a bit of a hack, but at least TypeScript shut up and stopped bugging me about it. So it's pretty cool. And the way I use it is basically just instead of using the standard router, I just inject navigation service, and then using that, I can call .navigate, and then this will navigate for me to the next page. One more issue, and that's not really an issue, it's actually something designed by, it's actually a design, but some people think it's a bit of a challenge. Imagine you have a situation where we want to do endless scrolling, okay? And then in this case, I had to import a special module just for the web, because in NativeScript we have list view, which kind of gives me this functionality by default. However, because I needed to do that, basically I had to install ngx infinite scroll and then npm install it. That meant I had to add it to my ng module. But this module wouldn't work with NativeScript, right? So what I really needed is actually have two separate ng modules, which would have all the shared items, but then the web one would have the unique one, which would be the endless scrolling. So as a result, then I could, for example, add the infinite scroll module to the web ng module, And then, for example, I'll get these additional properties for like infinite scroll and a scrolled event, which would allow me to do endless scrolling. And then for NativeScript, I wouldn't have that module. I would just use list view, which would use the load more items. But the cool thing is that they both call the add items 10 property as soon as you scroll to the bottom, right? So this is one of the things. So you could pretty much imagine that whenever you, for example, use web projects, you'd use Angular CLI to generate components and services. And at the moment, Angular CLI doesn't let you, let's say, construct the whole component or even whole module that has the whole shared elements. So you'd have to manually create the .tns files and put all the contents in there. But luckily, I actually created a library or like an extension to NativeScript CLI. So basically, if you call TNS extension install NativeScript Angular CLI, it will give you additional commands. So you'll be able to generate shared components and even generate shared modules, just like you would do in Angular CLI. So I've got a bit of time, so I'll do a quick demo for you. So here's, can you all see the code? Is it good? All right. So I'll show you. So this is a demo project I'm working on. It's called Pet Bros. It's based on real data. So what I have here is, like, for example, here's my Firebase abstraction, which basically covers the difference between Firebase, but we're not going to get into that too much. So the whole idea is, like, for example, what's going on? Oh, yeah, here. So my navigation is like, I have just one file for approutes.ts, and I have one common navigation for my whole project. So I have like my home screen, pet search, shelter search, and then I can get details for a specific pet, etc., etc. Also, I have my user service. So this user service specifically uses my Firebase service. So if I find the constructor, see, I'm using my Firebase user service, and I have Firebase data service. So this is actually the abstraction I created, but basically I just have one user service in my project. And this service allows me to kind of like call signing or log out, reset password, or even like add pets to the favorites or remove pets to the favorites. We're not going to argue that adding, removing records shouldn't be in a user service, okay? That's not the point. But it's just one service. And then, for example, if I go to my login module, just here, I have my login module TS and login module TNSTS. And for example, this one will import some material design components over here, while I'm not doing that for the NativeScript one. And for example, my login component would go and use the user service to sign in when I call login and then navigate to a home page. Same thing for register. And then, for example, in my UI, I have my form for like capturing email and capturing the password. But if I find the buttons, so for example, we have the button here. So I can call login, and then on login, I'm actually calling the login function just here. And then for NativeScript, I'm doing pretty much the same, except I'm using text fields to capture my fields. And then once I want to log in, I have a button. And then on top, I'm literally going to call login, which is exactly the same function. So we're literally talking about using the same components that use underneath the same service that uses Firebase underneath. Like all of it is kind of shared. And the way I can use it, let me just build a project, because I'm not going to show you all of it that's there. I can just run ngserve. And then this will build the application, and then I'll open it in my web browser. And then it's coming up. By the way, this is my Firebase data, so each user will have its pets, etc. So we'll be reading records from here. And that should log in. Yeah, so that's my login page. It's pretty, right? Come on, guys, appreciate it. I'm not a designer. Pity. Anyway, after I log in, I can actually go and get the real records. So these are like the favorites from this specific account. And then, for example, I can go and search for new pets. So I can go, search for birds. Let's search for young birds in Boston. And yeah, I see how it is. The internet is fast. I'm actually tethering to my phone. It's like, signal, give me signal, please. Oh, come on, I want to show results. You see, there are no young birds in Boston. What a shame. Oh, cats, let's see. I swear this works. There's no cats in Boston. Wi-Fi fun. Let's see. Okay. While this is looking for cats in Boston, I'm going to build a NativeScript app. So in this case, I'm going to go into a NativeScript folder, and I can call npm run iOS. So this is the custom build command. So this is just going to recreate the project very quickly, or just sync the differences. And then it's building the project for me. To be honest, this is from the previous build, but that's pretty much what should pop up. And then I can log in and then kind of like get the same records, just like I had over here in my homepage. So you see like Mischief and Bandit is here, etc. And then, oh yeah, now the build finished, so it's going to refresh. Let's see if the search at least works on the mobile. Once it refreshes, let's see. So find more pets. This time, I'm going to go more Christmassy, look for pigs. I don't care about any other parameters. Oh yeah, there you go. You get Skittles, you get Snickers, Charlie. By the way, this is real data. This is this service called Pet Finder, which works in the US, which has all the shelters. So if you want to adopt Charlie, let's see. Charlie's 3 years old, is a people pig. Wherever humans are, that's where he wants to be. Hey, I'm going to invite Charlie for Christmas dinner. Hey, not like that. I'm going to add him to my favorites. Add Charlie. It should appear my record. I wasn't open. Yeah, there you go. It's Charlie. So I can find it. They're like all interconnected, etc. This doesn't work super fast. On tethering is not always great. All right. So what I want to show you next is what if I wanted to make a change to the project, right? So I'm gonna try to do something else. So I can run tns generate a shared module, and I'm gonna call it a petter. So imagine we have somebody who pets the pets, okay? And that basically generated a whole module for me, and I can actually rerun the build. Oh, I need to be in the NativeScript folder for that. Was I still running this? Let me kill it. npm run iOS. Okay, so that's building. So what we have here is like basically just simple ng modules for NativeScript and web. I have my default routes, which has just an empty path. So because for now we just have one component. And what I need to do is add my service. So I'm going to import the Firebase and the data service. And what I need here is probably at private. Is that how you spell it? Yeah. Let's call it Petters. Pet Finder service of Firebase. All right. I got confused for a second. Firebase data service. Okay, so I'm gonna call it Fire service actually. And if I go to my Firebase database, you see I have this node for Petters. Okay, so I'm gonna create an observable. So public Petters. I'm gonna add $, and that's actually gonna be a Firebase list. What do you not like? Of type any. Fine. I actually should know the type by now. And then in my ng on init, I'm just going to do this patterns equals this dot fire service, and then I'm going to get a list, which is going to point to patterns. I think that's how you do it. Or is it slash patterns? All right, so this should create the patterns for me. And then from here, all I need is, let's say, I'm going to create an H1, and I'm going to just iterate ng4, so pattern of patterns, and then use the async pipe. Is that correct? Oh, let pattern, yeah. There we are. So I actually have the model for the pattern. So we have things like name, email. So we're just gonna display maybe name and a favorite pet. So pattern.name and pattern dot. I should have just added a type before. That would have been easier. So let's see. That should have rerun ng. Oh, okay. So that's the first step. The next thing we're gonna do, I'm gonna do the same thing with NativeScript. So what I'm gonna do is this. I'm gonna create a list view. So this list view is gonna get the data from patterns again. I don't need any of those events. Let item, so let pattern. I swear this is the most complicated part, or not. All right, so here we had pattern.name. So I'm gonna display a pattern.name and pattern.favoritePet. So this is really where the difference comes in. And let's see. So now we have the HTMLs, and pretty much one of the final things that we have to do in my navigation, so in my app routes, I need to lazy load that. So I'm going to add pattern that goes to the pattern module. So we're going to go to app/pattern/pattern module, get the pattern module here. So literally pointing to this folder over here. And then finally, let's skip the login page. And I'm just going to open with the pattern. So fingers crossed I didn't mess up anything. It wouldn't be the first time. Oh, come on, why don't you just display the data? That's weird. Let's see if it works with the NativeScript project at least. All right, TNS run iOS. Oh, I forgot to run LiveSync. That's why I didn't refresh. Unless I messed up the path. Let me just check very quickly. Pet details. Oh, no. User service. Yeah, it should be /user, so that's fine. All right, let's see. The build's still going. Fingers crossed, at least one of them has to work. If I can get it working in NativeScript, you believe half of the story, which is fine. I can go with that. Did I? Wait. This is not loading. Let's try to do it manually. This is pretty much the first time this didn't work. I blame it on Wi-Fi, by the way, which I'm not connected to, because I trusted my phone. Oh, the project didn't get synced for some reason. Oh, because I'm looking. All right, one last try. Package.json. So one of the things I didn't show you before is that the whole build is done through gulp that is just here. So I can technically trigger it manually by running npm run prep CLI tablet. And that should sync my project over here. All right, that loaded it. All right, so I can run tns run iOS, so manually step by step. So hopefully at least this will load the NativeScript by itself. One last try. Fingers crossed, all of you. Yes, there's few of you. Perfect. Let's see. The build's almost there. Installing the app. Come on, don't fail me. And there's no data. Is it just patterns? I guess you have to believe my word that normally this works. Wait, I'm going to check one last thing. Yeah, this seems fine. I think I messed up something with Firebase. Oh, God, I'm going to give you my T-shirt. All right, this guy is a real genius, and I'm being an idiot. Okay, you saved my life, man. That was totally planted. He's with me. All right, so there's actually an event called value changes. I forgot that the API changed, which basically returns an observable. So I don't really need a Firebase list. I need observable here. I can save this. I don't know how I didn't think about it. So my web project should work. There you go. So we're displaying Seba, super Gerard, right? It's cool. And let's see for NativeScript. We're almost there. So I'm just gonna manually just do this and run it. So that's the first part of it. And the second part should load in a second. See, so this was a real thing. Like, it wasn't me completely staged. You know, everybody makes mistakes. It's part of the live coding and doing the demos. And then once that calls, it's like the whole thing is like, I haven't built actually particularly anything amazing, but the idea was to kind of show you that we could just reuse the same services, the same components, same backends, and hopefully display the same records in a second. Once this loads, and we have, yeah, super Gerard. Right? Cool. Woof. All right. Given Shmuela is after me, I'm going to take extra 10 minutes. Thanks, Shmuela. So that was my demo. I still have just a couple of slides. So in terms of code sharing goals and plans, I want to cover, and that's very quickly. Actually, in a week, well, actually in 6 days, I'm flying off to California, where I'll be working with the Angular team, where we're trying to actually integrate NativeScript with Angular CLI. And the idea is that you should be able to use your existing web project, call ng-add NativeScript, and then this will actually convert your project to a code sharing project, and you'll be able to then after that start calling the NativeScript builds as well, which is pretty amazing. We're going to move away from the gulp build into the Webpack build, and that's because, oh yeah, you love it? Come on. And that's actually because at the moment with gulp, if I want to publish my Firebase library, I can't do it, but with Webpack, we could actually even dig in deeper into NPM modules, which will be pretty cool. And then we're going to look into a migration process. So right now, I can tell you the whole story, how you can build a project from scratch, but not necessarily how to convert an existing just yet. And then basically working on more real-life examples. So the pet bros is one of them, but I want to do one with like using like Salesforce and some other ones, and working on a workshop. So probably in a couple of months' time, I'll be back probably in Warsaw doing NativeScript code sharing workshops. So I don't think we have time for Q&A. So thank you for listening, and thank you for your help. All right, survived.